Hi everyone, Mr. Eugene now going to teach Pythagoras. So what is it, Pythagoras? Actually very easy, basic, straightforward stuff. Just having a right angle triangle and just telling this is A, this is B, this is C. We're just looking about the length of it. So A squared plus B squared equals to C squared. And that's it. That's the whole thing. What is it about? Have a look at example. For example, I have this triangle here. If I have the length for this is 3 cm, this one is 4 cm, what about this length here? Okay, so again apply to the formula A squared plus B squared equals to C squared, and I just apply to the formula saying okay, A squared, which is 3 square, and B squared 4 square equals to C squared. Okay, C, which is always the longest side of the triangle, and just apply to it. 9 plus 16 equals C squared. 25 equals to C squared, and C equals to 5. So which means this length here is 5 cm. That's it. So which means the length of the right angle triangle here, this is 3 cm, this is 4 cm, and there will be 5 cm. Alright, have a look of the other example. Let's say I have this one here. Okay, if I have this is 5 cm, this is 13 cm, and what about this one? X. Again, apply to the formula A squared plus B squared equals to C squared. Okay? Right. Come on, have a look. Again, most people, they have a mistake, say 5 is 13 and the A squared plus B squared, A squared plus B squared equals C squared, and then they say will be 5 squared plus 13 squared equals to x squared, like that, and they just calculate 25 plus 169 equals to x squared, blah 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 blah. Oh my goodness. Don't make this mistake. Come on, look at the question carefully. Ask yourself, which one is A, which one is B, which one is C? Look at this. 13 is the longest side, isn't it? Look at my previous slides. C is the longest side of the triangle, isn't it? So 13 is the longest side, so for the 13 you should put on the C part here. So this one here, you should put it here, not here. So most of the students make this kind of silly mistake. So don't make mistake. Should be 13 in here and x in here. We're looking for that. Okay? So some people ask me, hey sir, can I have 5 square in here and x square in here? I mean like x square plus 5 square equals 13 square. Oh yes, doesn't really matter. But definitely the longest side have to be 13. But this one, if you just swap around having x square plus 13 square, can I? Yes, absolutely fine. Okay? Right, so in here again, so x squared plus 25 equals to 169 here. So x squared equals to 169 minus 25, x squared equals to 144, and x equals to square root of 144, and the answer equals to 12. So here is 12 cm. Done. Okay? Right. That's generally about for Pythagoras. But sometimes you have to aware of the surd form. What's the meaning of surd? S-U-R-D. Surd simply just meaning square root. When we are having like let's say 196, we can just write the whole number equals to 14. Square root of 324, yes, I know, exactly 18. Square root of 729, I know, yes, 27. But what about 126? 11 point blah 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 blah. Okay? I don't know what sort of how many numbers at the back there. So for these kind of examples here, we are having some sort of simplest form. How? Okay. If the question asking you to simplify to the third form, have a look. E.g., square root of 126. Okay, go back to your primary school level. Okay, 126. Remember how to divide it into the prime factors? Divided by 2. What was it? 63. Yeah? Divided by 3, which is 21. Divided by 3, which is 7. Remember these kind of things? Yeah? Okay. So 126 just simply equals to 2 times 3 times 3 times 7. So for this case here, 126 square root just simply equals 2 times 3 times 3 times 7. Okay? Right. Because we know what? When we take the square root, we can, like, if got two numbers inside, we can just take one out and then put it outside of the square root part. So it becomes 3 outside. Okay? And with the stuff inside, for example, like the example here, just only got 1 2 here and got 1 7 here. We can't have any pairs can come up with, so we just only have a square root of 2 times the square root of 7 inside, like that. But of course, we can squeeze it together. It becomes 3 square root of 14, like that. That's our simplest form for square root of 126. Alright? Remember what we got. Okay, maybe I just some people don't quite understand what's going on with 3 times 3 square root becomes a 3 outside. Okay, if I have a square root of 25, what happened? Square root of 25 equals square root of 5 times 5, isn't it? Which is equals to 5 simply. Okay? So if I have a pair of 5, I can just take out what becomes 5. It's the same case here. A pair of 3, I come up a 3 outside. If I have just only got one number alone, I still have to copy a square root or something outside. Okay? Right. Try another example and see how it goes. E.g. 2. Square root of 288. Okay, again, have a go. 288, first of all, divide 2, 144, 2, 72, 2, 36, 2, 18, 2, 9, 3, 3. Oh, quite a long one. 2, 2, 2, 2, 2, 3, 3. Square root of 2 times 2 times 2 times 2 times 2 times 3 times 3. Okay. Again, pick the pair up. One pair. Second pair. Third pair. Can you guys see that? Yes? I said what? With a pair inside the square root, we can take it out. Become outside. Not necessarily under the square root thing. However, with this example, we got these alone. So what should we do? Copy. Okay? And what about those colorful stuff in here? Multiply out. 2 times 2 times 3 becomes 12. And this one here, just copy straight away. So our final answer will be 12 root 2. Make sense? Okay? Alright. Have a look at one other example to refresh yourself. E.g. 3. square root of 248. Okay, again, 248 divided by 2, 124, 262, 231. Okay, this one here, we just only have 2 times 2 times 2 times 31, and again only this pair we can take out, so we just say 2 and square root of 62. Hey sir, 62 is a very huge number. It seems doesn't look like, oh well, that's all we can do. So this is the final answer. Don't say, oh, this number is too big, it seems doesn't make any sense, isn't it? Don't think that so, okay? Just make it like that, okay? That's what we can do, alright? This is the final answer, alright? Now, another concept I would want to deliver is this one here, called rationalize. What does that mean? That means we don't want any square root stuff in our denominator, which is this one. Like here, for this example, what happened? In order to get rid of the square root here, we just simply multiply this. Yes? Right? Root 3 over root 3 just equals to 1. If we just multiply 1, doesn't make any difference, isn't that? So, multiply straight away. Root 3 times root 3 just equals to 3. And then 1 times root 3 at the top becomes root 3. Okay? Any problems? Very easy, isn't it? Yeah. Second, if we have 1 over 2 root 5, again, don't multiply 2 root 5. Just multiply root 5 is fine. Why? Because I just want to get rid of the square root. Don't multiply 2 root 5, just multiply root 5 will be fine. 2 times 5, 10. 1 times root 5, and that will do. Okay? Very easy. Okay? Alright, another example. What about like this one? 2 over square root of 12. Okay, this one is a little bit hard. Okay, again, do the same thing. Square root of 12, square root of 12, and we got what? 2 root 12 over 12. Yes? Alright. Is that finished? And of course it's no. Why not? Because we can simplify. Simplify 2 and the 12 becomes a 6. Okay? Is that finished? Is that finished? Of course not. Hey, look at this. Yes? Refer to what we just learned. Square root of 12 equals to 2 times 2 times 3, isn't it? So, we break into that and just equals 2 root 3, isn't it? So, that becomes 2 root 3 over 6. And we can simplify further, excuse me. So will be root 3 over 3. Okay? So this question is a little bit tricky. Alright? Any problems with that? Okay. Right. Another stuff that I just finally, before I finish off, is that if we have this one like 4 root 5 plus 2 root 3 plus 4 root 5 like that. Again, How are we going to do this? Well, like doing the algebra stuff, if we have the like terms, the same kind of stuff we call like terms in maths, we just mix them all together. Root 5 and root 5 are the same kind of stuff. We can just put them together. Root 3 cannot mix with the root 5, they're not the same thing. So, this one here, we just leave it. Only have these two terms, mix it. 4 root 5 plus 4 root 5 will be 8 root 5. And then plus 2 root 3. Alright, that's the answer. Okay. Alright. Another example. What about if we multiply? Say, for example, sir, if I have this one, multiply 4 root 5. Not plus, but times. Can we do that? Yes, definitely. Oh. Can we do this kind of stuff? Yes, definitely. When we are doing that, I always suggest my students do it part by part. Do the red one first. 2 times 4 times 4 first. And then do the purple stuff. Root 3, root 5, and root 5 later on. Okay? Okay, what's the red one? 4 times 4 times 2 equals 32. Okay. Root 3 times root 5 times root 5. Wait a moment. Here, I can make it as a whole number, isn't it? Becomes a 5. Mixed with the red ones. But the root 3 here. Okay? So, what's the red one? Becomes 160. And the root 3 just copy straight away. So that's our final answer. Alright? These kind of stuff just simply the same as the algebra stuff. If we have the like terms, we can add together. Unlike terms, cannot add them up. Just copy. If we multiply and then just kind of squeeze together. 2 times 4 times 4, like this case here, 2 times 4 times 4, like that. And then like the roots, can multiply the roots. Okay? Alright, that's about it for the Pythagoras and the suits. So hopefully you enjoy the course. Thank you.